Hi everyone, welcome back to my channel. In today's video, we are going to look at definite integral. Now, in my previous video that you may or may not have looked, called Intro to Anti-Differentiation, what we did was indefinite integral. So, just to recap a little bit, what we did before was indefinite integral, where basically we have just a basic function and we want to find the integration of it. So we're given basically the derivative and we want to find the original function. So it's the reverse process of differentiation. For a definite integral, it's very similar. Let's say we have a continuous function f of x. So that is, it must be continuous, that's a condition. And we have capital letter f of x. Let's call that the antiderivative. So that basically means the answer you get when you integrate something like this. So we know that f of x is continuous, and we label capital letter f of x as the antiderivative. Then, just like indefinite integral, we have a function f of x. We want to integrate it, but now instead of having just simply like that, we have a lower bound and an upper bound value, and that is called definite integral. And that would be equal to the antiderivative of b minus the antiderivative of a. So note that it's always going to be the upper bound value minus the lower bound, b and a. So I know this is a bit confusing, but we'll get used to it. To further explain, basically, definite integral helps a lot when you want to find area under the curve. So let's say you have a function like this, and we have a and b as our interval, and we want to find the area. And how do you do that? You do definite integral. So, before we start, I also want to introduce the properties. So, the properties for definite integral, we have the first one, very basic, is just basically we have the same thing as what we wrote earlier. We have this, same, okay? And that is equal to negative. If you want to change the negative sign, you must also switch the lower bound and upper bound value. And it's the same exact thing. Because what that basically means is we know that we always find the area under the curve. But let's say, what if the function is negative itself? We want to find the area from a to b. Well, if you want to find the area, but that graph is negative, then we simply need to switch the sign and switch the lower bound and upper bound value. Another property that you want to note is, again, we have the same thing, but now we have a constant in front. So k is a constant. Then if you leave it outside, it's the exact same thing. Oops. And sorry, I forgot, must always add dx every time you integrate. And then third, we have if f of x from a to b plus another value from b to c, let's say, then that would be equal to from a all the way to c. So I know this is also a little confusing, but let me just explain that real quick. So we have, again, let me just draw a graph. Let's say that. And now we have a, b, and c. So here, the first one is from a to b. Okay? And then the second one is from b to c, right? Well, if you take a look at that, that's the exact same thing as the area from a to c, from a to c. Okay? And last but not least, the fourth property that you want to know is if you have inside, you have a function plus another function, then you probably guessed it right. That is the same thing as separating them into two different integration and adding them. So it's the exact same thing when you separate them. So these are 4 very important properties for definite integral. So now let's try applying these to some problems. So for the first one here, we already see that this is a definite integral. We have the lower bound as 0 and upper bound is 1. And when we integrate this, note that because inside our function is not just x alone, it is 3x plus 1, I also want to introduce another thing. So whenever you see a function f of ax plus b inside, and we want to integrate it, when we integrate something, this is very similar to what we learned in earlier videos on differentiation, where we introduced chain rule. In integration, there is no chain rule, but it is a little similar. When you see an inside function, not x alone, we always have a special way to integrate it. So let's say we have ax plus b to the power of n. Then the integration of that, if I integrate it, it would then be equal to 1 over the inside function a times ax, the inside function, we write it all out. To the power of, just like what we did earlier, when you integrate it, it's always n plus 1. And we have to divide by the power. So n plus 1 divided by n plus 1. And remember to always add the constant c. So let's try applying this to the first question here. So the first thing that we want to do is, if we look back at definite integral, when we have a lower bound and upper bound, it's always going to be f of b minus f of a. And we know that f of x, capital letter, is the antiderivative. So the first thing that we want to focus on is not the lower bound, upper bound. You first want to focus on integrating what's happening in here. So we usually use the bracket, the big bracket, and then write the upper bound and lower bound value outside and focus on integrating inside. So we have 3x plus 1, right? And so here in our formula, we have 1 over a. And in this case, a is 3, so it's going to be 1 over 3, right? 1 over 3 times the inside function ax plus b, so 3x plus 1 to the power of n plus 1. 4 plus 1 is 5. It's going to be to the power of 5 over 5. And then we will plus c. But please note that whenever you do definite integral, the c always disappears in the end. So you'd never have to include c. So if I were to simplify that before we move on to the next step, we have 1 over 3. The bottom is 3 times 5, so we can just simplify that to 1 over 15 times 3x plus 1 to the power of 5. So now we're at this stage, and the next step we want to do is we want to subtract it. We want to first substitute it. So remember, it's always the upper bound value minus the lower bound. So here the upper bound is 1. So we want to plug 1 into x. We want to substitute it. So we get 1 over 15 times 3 plus 1 to the power of 5 minus, now we want to subtract the lower bound value. So we plug 0 into x. So we have 0 plus 1 to the power of 5. If we were to simplify that, we get 4 to the power of 5. And feel free to use your calculator at this point. And in the end, our answer is not going to be a nice number. It's going to be a fraction, which is 241 divided by 5. So there you have it. A little bit complicated for our first question, but I hope you get the gist of it. Now let's move on to a second question. So now we have if we're given that the integration from -1 to 1 for f of x is -4. Now I want to find from -1 to 1 of 2 plus f of x. So we can see that the lower bound and upper bound value remains the same. And how do we do this is we can make use of our properties. So which of these 4 properties should we use? Well, it looks like the fourth one is the one that we're going to use. Why? Because here we're going to find 2 plus f of x. And here we have two things adding together. And so let's try making use of that. So because we have 2 plus f of x, we can separate them into 2 different integrations. So that is the same as 2 plus -1 to 1 of f of x. Let's add the dx. And for the first one, well, if you think about it, a constant number 2, the value is going to be, well, if you think about it, 2 is just a constant number. That means that it is a horizontal straight line, y equals to 2. And we want to know from -1 to 1. So let's say this is -1 and this is 1. And we want to find the area. Well, that's basically just 2, right? The height is 2 times 2, right? So our value is going to be 4. Plus, we know that this value here, it says in the question, is -4. And so if we add them together, we're going to get 0. So there it is. That is our integration from -1 to 1 for 2 plus f of x. Now let's try the third one. This time we're given the area. So we know that our area is, we know that our graph given is sine 2x. And we want to find the shaded area. So first of all, let's write that down. So because we're finding the area, as I mentioned earlier, we're going to use definite integral. And what is the lower bound and upper bound? So from the shaded area, we're given that the upper bound is pi over 2. And here we can assume is 0. So it's from 0 to pi over 2 of the function sine 2x. So just like our first question, what we're going to do is we want to first integrate sine 2x. And sine 2x, if we integrate it, remember in our previous video for trigonometry, we know that sine x itself, if we integrate it, we're going to get negative cosine x. So it's going to be negative cosine x when we have sine x. But right now we have a 2. So again, if we go back to our previous equation, we got to make use of the special formula. So because the inside function is 2, we know that it's going to be 1 over that value. So it's going to be 1 over 2 times negative cosine 2x. And let me just provide some more space there. Okay. And if we were to simplify that inside, we're just going to put the negative sign outside to make it more clear. So it's going to be negative 1 over 2 times cosine 2x. And there you have it. Now, the next step is we want to plug these two values in and subtract them. So first of all, we do the upper bound. So negative 1 over 2 cosine 2 times pi over 2 minus, we plug the 0 in now. So minus cosine 2 times 0, which is basically just 0. So first of all, let's focus on this one. So we have negative 1 over 2 cosine pi plus 1 over 2 cosine 0. So now we're going to try to use the unit circle to help us solve for this. So okay, so we have pi here, and we know that the value, the coordinates, is going to be negative 1 comma 0, and for 0, it's going to be 1, comma 0. And we know that for cosine, it's going to be the x value. So we're just going to focus on the x value. So negative 1 over 2 cosine pi is going to be negative 1. Plus 1 over 2 cosine 0, that's 1. And if we simplify that, we get 1 over 2 plus 1 over 2, which in the end we get 2 over 2, which is equal to 1. And remember, because we're finding the area, it's going to be 1 unit squared. And there you have it. That is how you find the area using the definite integral. Thank you for watching.